Hey guys, I'm back, and this is the Nest E thermostat. I was really impressed with it, and it's got some cool features too that I didn't actually know about it when I bought it, that I want to kind of explain and take apart and see if we can figure out. So the neatest thing about this particular smart thermostat is that it doesn't require a common wire in most circumstances, depending on some other variables that I'll get into later. But basically, if you want to learn out more about this, you go here to technical information and then power, and it tells you the battery voltage inside the unit, the open circuit voltage, the voltage in, and then how much current it's actually drawing. So I'll explain that in a bit and show you how it works, but I'll just go ahead and take it off the thing right now. And then as you can see there, you got I think red is power, green is the fan, I think Y1 is air conditioning, and W1 is heat. But it mounts in there nicely. It's even got this little level indicator built right into the faceplate. So I mean, I was really happy with the way everything turned out. But I'll go ahead and I'll take this thing apart and explain some stuff to you guys. Thanks. Okay, so basically the way most air conditioning systems work, control systems work, is it's a 24 VAC system. So you get the sine wave that looks something like this. It has a peak voltage of around 38 volts, an RMS voltage of around 24 volts, and it looks something like this. And so basically what RMS voltage is it's the root mean squared voltage. So if you think of it as the average of the absolute value of this voltage, that's what it is. Alright, so once it gets rectified through this thermostat, because it's a computer, so we know it has to run off of a DC power source, you end up getting some waveform that looks something like this, where you got these peaks, no more negative voltage. And then if you add a capacitor to that circuit, you get something that looks like a pretty smoothed out 38 volt line here. And so that's where they get their 38 volts open circuit. Even though it's a 24 volt AC system, it still has a peak voltage of about 38 volts, which is one of the principles this thermostat operates off on. So if we flip this around, actually right here, so this is basically what the circuit of this Nest thermostat looks like. You have your power supply here, about 24 volts AC, and rectified, that's like 38 volts peak. And this is when the unit is off. So when the air conditioner is off, this is what's basically going on here. And so it's drawing a little bit of current through these coils, because we don't have a common wire hooked up. This is if you don't have a common wire hooked up. And so you get a little bit of a voltage drop across this, but it's not enough to make the coil actuate. So it's drawing a little bit of power through the coil, but it's not enough to make it actuate. It's only 40 milliamps, and at 36 volts is what the thermostat's getting, but it's only about 2 volts DC across each coil. So that's all right. And so if we do the math here, the power that the thermostat's actually getting from this is 1.44 watts. And I guess that's what they decided was the safest, to make sure that, like, you know, the air conditioner didn't get confused or anything, and it didn't turn on when it's not supposed to. Because really, like, the way these thermostats were hooked up, it was never supposed to be operated like this, because they didn't have smart thermostats when they installed units like this without common wires. But they've been able to make it work. And so 1.44 watts, you know, your Apple iPhone, the little cube charger that it comes with, is a 5-watt charger. So it's not a ton of power, but it's enough to sustain the thermostat. But this is when the unit's off, the AC unit's off. Now when it's on, what you're going to get is, you know, like 0 volts across one coil, and then like something slightly less than VRMS across the other 2 coils. You know, so you got one for your fan and one for your heater, your air conditioning. So if you say you got 23 volts on this, that means there's like a 1 volt AC voltage drop, or, you know, with the peak to peak voltage, however it works, If you go into the thermostat and you look at those settings that I showed you previously, when the thermostat's or when the unit's on, it's about an 8 VDC voltage drop that it's getting. So, and that's at 20 milliamps. So if we do the math there, then the power is only 0.16 watts when the unit's on. So your thermostat is actually receiving less power when the air conditioner or heat is running versus when it's off. And that's why this thermostat has to have a battery, is because if it relied only on the power whenever it turned on, it probably wouldn't be enough to keep the thermostat running. So it has to charge up when it's getting more power in the off state so that it can run it through the on state. Which is why if you're having problems, maybe if the thermostat's old, the batteries start to go down, it might just make more sense to hook up a common wire, in which case you just bring this over here and then your thermostat would have a constant 24 volt AC power supply and you wouldn't have to worry about any of this. But now I'm going to take it apart, and because I wanted to see what kind of battery was inside of it and what the circuit looked like and everything else. But I hope you're finding this interesting. Okay, so it really just came off. I just used this thing that I had to take my iPhone apart with, and I just put it in here and popped it off, and it just kind of popped off like you would expect. That's the button that presses when you push the thing in, and I don't know, I guess I'll take some more screws out and see if we can find the battery. I mean, it looks really impressive. Like, they really put some time into this. Really well thought out, well engineered. Something I'm realizing too is that the spring action you get for pushing the thing in, it looks like it's made by these little bent pieces of metal, and it looks like they just use a lithium battery tab welder or something to spot weld them in there. Go ahead and take this off. And when I got it too, the battery was at like 3.7 volts, which I think is like a lot of manufacturers ship batteries at that voltage because it's like the safest voltage as far as shipping's concerned for lithium batteries. Well, I guess this is just the screen. Sorry, you can't see it. It's the part number. That's pretty cool. So I guess like when you turn this, this might stay still and this thing rotates. I see. All right. Well, let's look at this. This might be more to some other people other than me. Can't really say. But here's our battery. All right, made in China. PN. Da 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 da. I do not see a milliamp hour rating on there though. I don't know what that is, or what this other stuff is. My guess is this is some sort of sliding contact. We got our little blinking light there. Looks like it's got a protection circuit inside the battery. I don't know, pretty cool though. Pretty cool, I like it. I've used it a lot so far. And my guess is too, like if your battery gets low or something, not that you would want to, you could probably just plug in your USB port there and plug it into a computer or something, charge it back up. I don't really know what else to comment on though. But yeah, thanks for watching. So I'll go ahead and I'll put it back together. And if you like the video, give it a thumbs up and consider subscribing. Thanks. Alright, so here it is. I had a little bit of trouble. One of the connector for the thing that attaches, the thing that plugs into the base plate, there's another end of the connector inside the thing, and it got unplugged. And so when I plugged it in, it told me to connect it to the base, and I already had. So I had to take it apart and fix that. But other than that, it all went back together smoothly, and it looks to be working great. So that's what the inside of the Nest Thermostat E looks like. Pretty well designed. I like it. So thanks for watching. Bye.